Hello, everyone. In this session, we'll discuss about spanning tree and to be very specific, minimum spanning tree. Let us consider this network diagram, which are connected through these nodes. The circles are called nodes. So I will say circles are called nodes or vertices. Then these nodes are connected through what is called as arcs or also called as edges. Either you say arcs or edges or arrows, right? Uh, so this line which is connecting these nodes 1 and 2 and then 1 and 3, 2 and 3, these are called as arcs. Then in most of the network diagrams, you may find a direction, means rather than only line, you may find with an arrow. And in this network, there is no arrow, means 1 and 2, or you can also say 2 and 1, right? The distance between 1 and 2 or the distance between 2 and 1, you may consider it as 5. So this numbers 5, 6, 7, 6, 8, 8, 8, 6, all these numbers are called weights. Either you call it as weights, and these weights are, these weights can be either distance, depending on what is that we are drawing the network. It may be distance, or it may be time, or it may be cost. So that means any of this distance or time or cost, one will be interested in minimizing that only. So this is about a network diagram. Now, this network diagram is completely closed, right? It is almost forming a circuit. Whereas here, this is also a graph, but it is called as a tree because it is not closed. It is 1 to 2, 2 to 4, and 4 to 3, or 3 to 4, 4 to 2, 2 to 1. It is open on one side, so you call such thing as a graph. This one is also a graph, 1 to 2, and then 4 separately a node. This one is also a graph, but it is not connected. Now, this one, if you look into this diagram, this network diagram, and this graph, you may notice all these vertices are there. 1, 2, 3, 4, 5. All these vertices are available here also. 1, 2, 3, 4, and 5. And the arcs are connected to these nodes. This, in case if you have the same number of nodes in a graph, with one less arc, means here you may notice there are 5 nodes, or I can say 5 vertices. There are 5 vertices, and how many arcs? 1, 2, 3, 4. 4 arcs. You call this as again a tree, but you can also call it as spanning tree. Spanning tree. Again, from this network, I again made one more graph wherein all those 5 vertices are there. 1, 2, 3, 4, 5. All those 5 vertices are there, but it is different graph compared to this. This graph and this graph are different, but this is also a spanning tree. What is exactly a spanning tree? If the tree formed a tree which contain all the vertices of the original graph, and connected or called or I should say is called a spanning tree. So both this figure is also a spanning tree because it has got the same number of vertices like the original network. Here also it has got the same number of vertices like the original network, and it is connected. Both are connected, spanning tree. Now, in the first spanning tree, the total weight equal to, let us add the distances, 5 plus 8, 13, 13 plus 7, 20, 20 plus 6, 26. And then second spanning tree, the total weight equal to what? 5 plus 8, 13, 13 plus 6, 19, 19 plus 6, 25. Let me call this as second spanning tree. This one I will call it as first spanning tree. So we wrote the total weight for both the spanning trees. So I can say, compare to these two spanning trees, comparing these two spanning trees, the second spanning tree is considered as minimum. M stands for minimum spanning tree. Means likewise, there may be many spanning trees possible from the original diagram. From this diagram, there may be a possibility of many spanning trees, out of which whichever is giving you the least total weight or least total time or least total cost or least total distance, that you call it as a minimum spanning tree, right? In case if you find this find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channels. Thank you.